So today I'll introduce you a technology which is a drone. So over the day I've been part of two seminars where aerial drones have been used. So I'll be talking about something called underwater drones. So these are remotely operated vehicles that we have developed over the last 7 years. And these are typically for underwater robotic inspection and service solutions. In interest of time, I'll be a little quick about this. So overall, bridge substructures require regulatory requirements for inspections for these. And also aging infrastructure plays a very important role. These inspections are done to avoid any catastrophic failures of any bridges. Currently, the methods done by these inspection methods are manually done, like say by divers. And these have limitations when they come to depths they can go to, the endurance they have, the carrying capacity, and the data captured is non-repeatable, it's not that very steady, and they cannot really pinpoint where the problem is. And overall, safety is also an important concern here. So what does a robot do? So the robot is deployed in the water. There's a control station where all the data comes back live. All the bridge engineers and the ROV pilot can see it live. Now the advantages of these systems are, it's a robotic technology, so it's an extremely steady data capture. We can tag the defect with the depth and in which phase of the pier we're seeing it. There's no risk to human life. We can do about 8 to 10 hours a day continuous operation, and we can go up to 200 to 300 meters of depth. So this is broadly how it works. So from a boat or a fixed location, you launch the vehicle. You have various photographs there showing how it's set up. Once it's deployed, the bridge engineers see live what's happening here. There's no risk to any humans in this complete operation. And you get live, extremely live visual data coming back. And the bridge engineers can operate and tell, go left, go right, this is what I want to see in detail, and so on. So I'll just move to the videos here, and I'll talk more about the technology we have. So this is the first one we built. So the video is shown in a swimming pool to make, just to show how the ROV works. So you have onboard propulsion, so we can go in all directions possible. It's deployed by a 2-member group. Sorry for that. So it's deployed by a 2-member group. All data comes back live, and it is electrically, it is powered by external generator. And it has lights, cameras, and various sensors on board. We can also do various kinds of cleaning on it. So this is a cavitation cleaner mounted. It is similar to a water jet cleaning, but it's much more, the pressure requirement is not very high, and you can expose the complete material and remove soft to medium biofouling growth. So there we are demonstrating cleaning of corrosion on a steel plate. So a lot of times the rivers have a lot of turbid water in it. So we've devised a clear box technology that allows, even in turbid waters, to see through clear water and get data. So this is captured in a project we did for Southern Railways, and we were able to gather good quality, high definition videos. Even in turbid waters. And after this, we also do a lot of image processing to get more detailed images out of that. So we've done about 3 projects for Southern Railways, and we're doing 2 projects for Southern Railways and 1 for Northern Railways, and we have 2 for RVNL lined up. So just to give an example, so for Southern Railways, we inspected about 16 pairs. This is how we do our reporting. A separate tab calls about the defects, and so this identifies in which phase of which pier, at what depth the defect is located, and on clicking that, you only get a video of that defect. This kind of platform is interactive and very useful to the top management to overall just know what are the problems and address the same. Thank you so much. We have a stall here, stall number 90, where we also are demonstrating the robot itself, and we'll be happy to come around and see it. Thank you so much.
Thank you, Mr. Khan Diljiwala, for introducing us to a new and latest technology on the subject. Now I call upon Mr. Abhishek Pandey, Business Development Manager, Hexagon India, for his presentation on subsurface mapping and detection system. Mr. Abhishek Pandey.
Good afternoon, everyone. Thank you, one and all. Thanks for providing this opportunity to present what we can support. I was collecting data for this particular presentation, and I was amazed to see that as we, Indian Railways, we are covering more than 120,000 kilometers, means 1,20,000 kilometers, with 114,000 bridges. It's amazing. And I was, of course, amazed to listen that news that the highest bridge today is 7 times higher than the highest pillar we do have. It's amazing. And thanks to everybody who's offering the technology, driving us more toward the technology, more toward betterment in our railways to serve our country. In addition to this, what I can offer, what we can as Hexagon India, we can offer, we are of course building the rail tracks, we are building the bridges, we are building the tunnels. Then what? Certainly, we need to maintain the health of our airports. So being in Hexagon technology, what we offer, we do have safe rail system. We do have safe rail system, we do have tunnel monitoring, we do have bridge monitoring, and certainly we do have the landslide monitoring, the bridges or the railroads on our hills. Because of the time, of course, I'll just wind up. Firstly, what we do in track monitoring. It's blast monitoring. We monitor the health of blast, we monitor where the blast is crossing, where the water is getting. With the speed, as our users were mentioning, the speed requirement is 160 kilometers. We do have a capability of move our system at a speed of 300 kilometers. That means faster, but certainly it depends the track we are being offered. And somebody was of course mentioning that we need a videography or the video monitoring of the tracks while doing all these things. We do have that capability. We'll be providing the video footage, we'll be providing the data, we'll be providing the 3 surfaces of glass. We do have 3, not unlike Austria. We do have 2. We do have 3 surfaces of glass, and of course we can provide those. As of now, our systems are working in 18 countries, 18 different countries globally. Coming to next thing, the tunnel monitoring. We do have a capability to monitor the health of tunnel, the corrosion inside the tunnel, the cracks inside the tunnel. So honey hoops, tunnel rates, water infiltrations. This is a report which tells us the different positions of the tunnel, the rebar position, the depressions. Just running fast. I believe it's fine. So you can see the difference between the concrete slab and the rock bed. We can monitor these things. Now coming to the bridge monitoring. See, we do have a system which will tell you that how much load. Oh, excuse me. Okay. So of course the bridge monitoring system will help us the bridge. This particular system will tell you the definition of on bridge on the load and rest position. So in this particular it is telling us the deflection within 3 mm. So we can monitor sub-mm deflections. And of course we can have the positioning of that particular point and we can deploy the maintenance part. Position in the sense of cord gates. Shade, real-time monitoring, deformation, particular structure, of course, with the blocks, names, and position of the structures, with sub-mm accuracy, that is 0.1 mm, we can avoid. This is a report, one of the examples of the report where we have measured displacement report at one particular point and how much it is displacement. This is landslide monitoring for our hilly areas where we are of course putting up or planning to put the rail line or existing one. So we can monitor from a distance of 4 kilometers. If we don't have an access, we can monitor from a distance of 4 kilometers. We can cover a span of 4 kilometers with that particular machine, and again the accuracy is sub centimeters and real time.